Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we are going to discuss about rotary intersection. So in this video lecture, the discussion will be only regarding the theoretical concept of rotary intersection. That is, we are going to discuss about what is rotary, what are the advantages of rotary, what are the disadvantages of rotary, when should we go for rotary intersection, and what are the design parameters for a rotary. So this is what we are going to discuss in this video lecture. Mainly, this lecture will be focused on theoretical concepts. We are going to do a small numerical regarding one of the design parameters, but on and all, the discussion will be theoretical concepts. So if you are looking for a theoretical concept, this is the video. And in future, as in when a numerical on rotary intersection is created, the same link will be the link of same will be posted either in the comment section, in the description box, as well as in the cue card, right? All right. So let us start with the rotary intersection. So before I move to the rotary intersection, let me just touch a bit about the uncontrolled intersection. So we have discussed about the uncontrolled intersections in the previous lectures, and there we have seen, like in the uncontrolled intersection, like in case of, let's say, two-lane road, we have 24 conflict points, which increase to 32 conflict points if we include pedestrians also. And these conflict points are reduced if we convert this two-lane road into one-way, one-lane road, right? If we convert it into one-way, one-lane road, then these conflict points are reduced to a much greater extent. But this is not a universal solution. We cannot in every situation convert the all the intersections into one-way roads, right? So we need to find an efficient method. This may be economical, converting road into one way, but that is not efficient. So we need to find some efficient method to channelize the movement of traffic along the intersection. So these uncontrolled intersections, we construct some structures or we install some traffic management strategies by which this uncontrolled intersection is channelized. What do we mean by channelized? That is, we force the vehicle to move in a certain way. And when we do that, that is called as the channelization of intersection. Right? We force the vehicles that are moving on that intersection to move in a certain path, in a certain way. This channelization is done either by constructing of a rotary or a roundabout. If that is a scenario, it is called as the rotary or a roundabout intersection, or we install traffic signals along the intersections. And when we do that, that intersection is now called as the signalized intersection. Okay. So the channelization of intersection is done either by construction of rotary or a roundabout or by signalization of intersection. Right. So we are going to discuss about these intersections in details. The intersections are divided into two categories. We have at-grade intersections and grade separated intersections, where grade separated are again bifurcated into two. That is the grade separated intersection with interchange and without interchange, where interchange is a facility for movement of traffic flow between two or more roads at different grade separated junctions. Right. We are going to discuss about this this grade separated intersection in detail in the upcoming video lecture. So we won't touch this topic. Just for your information, I have put it here. Right. So at-grade intersection is when the intersection is at the same elevation point, right? When the roads intersecting are at same elevation, that is called as the at-grade intersection. And the channelization of at-grade intersection is done by construction of rotary. All right. Now let us discuss about this rotary intersection. What is rotary intersection? So rotary intersection is a specialized form of at-grade intersection laid out for movement of traffic in one direction around a central island. So what does this mean is that first of all, the rotary intersection is a at-grade intersection. It is an at-grade intersection where the traffic is forced to move in a certain direction along the central island. Let us discuss about this. So in a two-way, two-lane road, we have the vehicles moving in this direction, vehicles moving in this direction. We have vehicles moving here, here. We have vehicles diverging from one and merging into the other. So doing so, number of conflict points are created. But in case if we construct one central island at this conflict point, if we create a central island in this conflict point, so what happens is that the vehicles that are crossing right now, if you see, these vehicles are crossing right now, right? These vehicles are crossing and diverging right here. So by constructing a central island, this is the central island that we have constructed. What we have done is we have forced the vehicles to move in a certain pattern, right? We have forced the vehicles to move in a certain pattern, in a certain pattern, and by doing so, we have reduced the conflict points in a very drastic way, right? We have reduced the conflict points in a very drastic way, right? So that is what your rotary or a roundabout is. There is a difference between rotary and roundabout, and we are going to discuss about the difference in detail. But first of all, let us understand the basic concept, right? So what we do is we construct a central island. We construct a central island, and through this we force the vehicles to move along this central island. That is, through that we restrain the vehicles to move in a certain way that was moving in a uncontrolled intersection, and thus reduce the conflict point drastically while not compromising with the traffic volume that will pass through the intersection. All right, that is what your rotary is. Again, I will repeat, it's a specialized form of at-grade intersection, very important, laid out for the movement of traffic in one direction around a central island, right? Around a central island. Objective, why do we need to construct a rotary? We have discussed just now that the objective is to eliminate the necessity of stopping even for crossing stream of vehicles and to reduce the conflict area. What does this mean is that these are the conflict points that will be created, right? So in order for a vehicle that is traveling from in this direction, and there is a vehicle that is traveling from here to here. So what will happen is either there will be an accident that will take place, or any one of the vehicle will slow down, right? Any one of the vehicle will slow down to avoid this accident. So by constructing a rotary or a roundabout, we eliminate this behavior, right? We reduce the conflict points while we ensure that the vehicles are now moving without much compromising with their speed. All right, so that is what the objective that we try to achieve by constructing a rotary or a roundabout. So the advantages of rotary is, first of all, the first advantage is that the crossing maneuver is converted to weaving, merging, and diverging operation. Again, here taking this image again as a reference, the crossing maneuver was now converted into a weaving phenomena, right? A weaving pattern, right? So by doing so, we have converted a crossing maneuver to weaving, merging, and diverging operation. We give equal opportunities to all the vehicles to move across the intersection without much compromising with their speed. The necessity of traffic police or signals is almost avoided. In case the traffic volume is very high, especially in the peak hours, if the traffic volume is very high, so only in that scenario we will install one traffic policeman, or let's say there is too much traffic coming from one direction, so then only we'll install a traffic signal. Otherwise, there is no requirement. The traffic stream adjusts itself along the traffic, this island, right? There is very little cost of maintenance for a rotary compared to the traffic signals. And the another advantage is, if proportion of right turning traffic exceeds 30% for four-leg intersection, a rotary is more advantageous than the traffic signal. So by four-leg intersection we mean, by four leg we mean these are the legs, right? This is leg 1, this is leg 2, leg 3 and leg 4, right? So in case of four leg intersection, if the right turning traffic, exceeds 30%, then rotary is more advantageous than traffic signal, because in traffic signals what we have traffic coming totally at halt in the red light, while in rotary that is not the scenario. In rotary the idea is the traffic is constantly in motion. Wherever the vehicle have to go, they are always in motion, right? So in case where the traffic volume is higher, right, especially the right turning traffic is higher in than 30%, like exceed 30%, then then we have to look into the possibility of construction of rotary before we go for the installation of traffic signals. All right. Now there are certain limitations also of rotary. The limitation is that first of all it requires large area of land. This is a practical or a actual image of a rotary, and you can see how much area is required, right? How much area is required for the construction of this rotary, right? So that is one limitation. Suppose we don't have that much area, then of course we have to look into some other traffic management scenarios. Another limitation is that it is not very effective when pedestrian traffic is large, right? Or the efficiency of rotary is limited in case of mixed traffic. For homogeneous traffic, that is when if in case we want to control the movement of vehicles across the rotary intersection, right? If that is the scenario, then the functionality of the rotary is fairly high. But in case we want to have pedestrian crossing also, like we have just now discussed, that the idea is that the traffic should always in motion. The vehicle should never stop, right? The vehicle should never stop. They should be always in motion. So having pedestrian crossing, there may be a location where the rotary is in vicinity of population, right? So in that case, if we have to construct zebra crossing, then the whole idea of constant movement of traffic is minimized, right? We have to look into the safety of pedestrians also. So that is a limitation of rotary, that in case of mixed traffic conditions, in case of if we have cycle like cycles also moving on the rotary side, we have pedestrians also moving on the rotary side. So in case of mixed traffic scenario, the efficiency of rotary is minimized. Construction of rotary is not suitable when angle of intersection of two roads is acute or have 7 or more intersection or intersecting legs. So we have seen that conventionally rotary is having 4 legs, right? And even in these 4 legs, suppose the overall or the natural intersection is like this, right? The intersection is like this. So in that case, all the construction of rotary becomes a very critical design parameter, right? Where this angle is very acute, right? Or in case we have multiple legs intersecting. So again, there construction of rotary is not a desirable scenario, right? Though it can be constructed and it can work efficiently, but it causes certain amount of confusion and everything. So that is why it acts as a certain limitation of rotary, right? When the angle of intersection of two roads is acute or have 7 or more intersecting legs, then the efficiency of rotary decreases. Another limitation is that we cannot construct rotary when traffic volume is low, right? Because construction of rotary, initial cost of construction of rotary is very high, right? Compared to the installation of traffic signals. So in case the traffic volume is low, then the installation of or the construction of rotary in that intersection is not advisable. So there are certain guidelines for construction of rotary type intersection. The first is, when should we go for the construction of rotary along an intersection? So the first one is that in case the traffic volume is greater than 500 vehicles per hour for all intersection layers. This means that in each of the legs we have a traffic volume of 500 vehicles per hour, or a total traffic volume of 3000 vehicles per hour entering from all the intersecting legs appear to be maximum practical capacity of high type rotary. This means either 500 vehicles per hour from each leg, or throughout the intersection. Throughout this intersection, we have a traffic volume movement of 3000 or 3000 plus vehicles per hour. Right? If that is the higher traffic volume is moving along the intersection, so then only we should look into the possibility of construction of rotary in that intersection, because since traffic volume is high, we want the constant movement of traffic along this rotary intersection. All right. So that is one of the primary guidelines that is needed to be taken care of when we have to look if we are going to construct for a rotary in that intersection. In case an intersection is having higher amount of right turning traffic, in case when proportion of turning traffic is high, or if we say like right turning traffic, if right turning traffic is high, then we go for rotary construction. In case there are 4 or more approach junction, then again we go for rotary intersection. And when we have the approach width restricted, right, in that case we go for the construction of rotary type intersection. All right. So just for reminder, this is a rotary. So if you observe, we have one central island, right? We have certain restrictions around the rotary. We have legs 1, 2, 3, 4. In this case, we have 4 legs, right? We have certain curve path. We have certain width available, right? We have certain width available that varies. So we are going to discuss what all these parameters are called in a rotary. So let us discuss through a diagram. So let's say this is our rotary. All right, this is our rotary. Now in this central island, this is the central island. And this whole diameter is called as central inscribed diameter. If a vehicle is approaching through this direction, so there is certain width available. For this vehicle. So this width is what we call as the entry width. This width is what we call as the entry width. Right? This is what we call as the entry width, and of course the vehicle will move through the entry width, will weave out, and if let's say he wants to go in this leg, and will go here, right? So this width available is what we call as the exit width, right? This is what we call as the exit width. This section of rotary is called as the weaving length, and this is called as the weaving width. This is called as the weaving width, right? So in each direction, this is the weaving length, this is the weaving width, weaving length, weaving width, weaving length, weaving width. Alright, this is the weaving length and this is the weaving width. Right from where the curvature starts, is what we call as the entry radius, and this will be called as the exit radius, and this is called as the exit radius. Now, in this rotary section, we have this central island. This is the central island. Along with that, if you observe, there is another circle that is inscribed. Right? This is the another circle that is inscribed. So the diameter of this, right from here to here, the diameter from here to here is what we call as the inscribed circle diameter. Inscribed circle diameter. And this width between the inscribed circle diameter and the central outer of the central island is what we call as the circulatory carriageway width. This is what we call as the circulatory carriageway width. This is what we call as the circulatory carriageway width. Alright. So important parameter for you to remember here. Important parameters are the weaving width, weaving length, the entry width, the exit width, entry radius or exit radius, the radius of central island. These are the main parameters. Apart from that, we have this what we call as the inscribed circle diameter and the circulatory carriageway width. Alright. Okay. So next we have is the design of rotary. So before I move to the design of rotary, let me first of all discuss the difference between rotary and roundabout. Okay, let me discuss the difference between rotary and roundabout. So on and all, the structure of rotary and roundabout is same, right? Structure wise is same, but your roundabout is smaller in size compared to that of a rotary. Your roundabout is smaller in size compared to that of a rotary. Second is that your roundabout works upon the gap acceptance and priority rule. Your roundabout being smaller in size. So what happens is, I'll just draw for example, if this is your roundabout and this is your rotary. This is your rotary. Okay. So roundabout being smaller in size, so there is not much width available, especially not much weaving width is available. So what happens is that there are movement of vehicles in every direction, right? At the same time, there will be movement of vehicles in every direction. Right? There will be movement of vehicles in every direction. So what happens is, based up this roundabout works upon the gap acceptance criteria. This means that if a vehicle is approaching from here and there is any vehicle that is approaching from this direction, so one will slow down and the other will pass, right? One will slow down and other will pass, right? So this, it works upon the gap acceptance criteria or the priority rule. While in rotary, the movement is based upon the weaving section, based upon the weaving behavior. This means here there is ample amount of weaving width available. So in case like if there is multiple vehicles moving in the same direction, so they have certain like ample amount of space available to move from one place to another, right? So it works upon the weaving behavior. Roundabout being smaller, so a relatively low speed is maintained in your roundabout, while in rotary relatively higher speed is maintained. In roundabout, no pedestrian activity is there in the central island. So central island we have discussed. What is central island? The central part, right? This is your central island. So if we talk about this, this is your central island. So in roundabout, central island being smaller, so there is not much activity can be planned in the central island. While rotary have a bigger central island, so it can be used either as a pedestrian crossing, it can be used either as a small park, it can be used for multiple purposes, right? Your roundabout has large entry angles that has to create entry deflection and to control speed through the roundabout, while the entry angle is relatively smaller in the rotary. The inscribed circle diameter for a roundabout is 28 to 40 meters for a single lane, 40 to 70 meters for a double lane. While the inscribed circle diameter for rotary is 70 meters. Inscribed circle diameter, what is inscribed circle diameter? This one. The diagram is now become hotspot, but this is your inscribed circle diameter. This is your inscribed circle diameter. Okay, if we look into this image here, this is our inscribed circle diameter. Right? Inscribed circle diameter. This is our ICD. Clear? I hope it's clear to you all, right? So this is the basic difference between rotary and roundabout. These are the basic difference between rotary and roundabout. Construction wise same, but dimension wise and like there are certain other parameters on which they differ, right? So it is not an interchangeable term. All right. So now let us discuss about the design of rotary. Okay, let us discuss about the design of rotary. So after deciding the shape of rotary that we are going to be using, there are certain design steps that we have to follow. So the first is to have a design speed. So in case the rotary is to be constructed in the rural area, a speed of 40 km per hour is taken, while for urban area, speed of 30 km per hour is taken. Reason? Urban area has a higher traffic volume compared to the rural area, so like higher speed is taken for the rural area. Then we have a radius of rotary, and the minimum radius of traffic island is what the minimum radius is. We do not provide any super elevation, and R equals to V square by 127F is the formula that is used to find out the minimum radius, where F is the coefficient of friction taken as 0.43 for rural area, 0.47 for urban area. Okay, this is the formula to find out the minimum radius. The radius of entry is taken as 1.33. The minimum radius for entry is taken as 1.33 into R entry, which is for rural road taken as 20 to 35 meters, and for urban roads taken as 15 to 25 meters. Width of carriageway. At entry, the minimum width of carriageway is taken as 5 meters, and depending upon the width of approach road, this width of entry is adopted, right? So if the approach road width is 7 meters, entry width of 6.5 meters given. Likewise, for if the width of approach road is 10.5, then 7 meters taken. For 14 meter, 8 meter entry width is taken, and entry width should be equal to the exit width. It makes sense, right? Because the same amount of traffic volume will be going, might be going from that other leg of the rotary. So attempt is being made that E1 should be equal to E2. Width of weaving section will be equal to E1 plus E2 by 2, that is entry width and exit width, sum of entry width and exit width divided by 2 plus 3.5. So that will be the width of weaving section. Length of weaving section will be 4 times the width of weaving section, right? Length will be 4 times the width of weaving section. And as per IIC guideline, if you are taking design speed of 40 km per hour, the length should be 45 to 90 meters, and for 30 km per hour, 30 to 60 meters. That is the range that is given by IRC. Now, the capacity of rotary is found using the formula QP equal to 280W 1 plus E by W, then 1 minus P by 3 divided by 1 plus W by L. W is the width of weaving section, L is the length of weaving section, E is the average of the entry and exit width, E1 plus E2 by 2 divided by width of weaving section 1 minus P by 3, right? E is equal to E1 plus E2 by 2, L is the length of weaving section. P, this is the new term, right? This is the new term that we are discussing. P is what we call as the weaving ratio. P is what we call as the weaving ratio, which is equal to B plus C divided by A plus B plus C plus D. We'll discuss about these terms. So P is what we call as the weaving ratio, which is the ratio of total weaving traffic in between the study area, divided by total traffic in the weaving section. So which is equals to B plus C divided by A plus B plus C plus D, right? Let us discuss this in detail. This is a very important term. So basically what happens is that we have 4 legs of rotary, right? We have, let's say, 4 legs of rotary. We have leg 1, leg 2, leg 3 and leg 4. So what we do is, in order to find out the weaving ratio, we assess any 2 legs at a time, and by considering the 2 legs at a time, we try to find out the ratio between the movement of traffic in between the weaving section. So what we can do is, at a time, either we can take traffic at 1 and 2, or we can take traffic in between 2 and 3, or we can take traffic in between 3 and 4, that is this section, right? Or we can take traffic in between 1 and 4. The thing is, we are going to move in the clockwise direction. All right. So we consider at a time any 2 legs of the rotary, and we try to find out the traffic that is moving in between the weaving section. Okay. So let us consider any leg. Let's say we consider leg 2 and 3. Right, we consider leg 2 and 3. So the section that we are going to consider is this section, right? The section that we are going to consider is this section, right? So we'll have this section. So let us represent it in the form of diagram. So we have a part of the central island, and these are the legs, right? These are the legs, let's say 2 and 3. All right. So here, what we try to find out? The proportion of traffic moving in different directions. So first of all, there will be a traffic that is coming from 2 and going to 3. There will be a traffic that will be coming from 2 and going to 3. That is all the left turning traffic. So that we represent by A. Then we have a traffic that is moving, that is coming from 1 and maybe going to some other leg. The leg may be leg 3 or leg 4. Got it? Coming from leg 2 and going to some other leg. The leg may be leg number 4 or leg number 1. Right? So that is represented by B. A is the left turning traffic. The traffic is coming from 2 and going to 3. Traffic coming from 2 and going to 3, that is what is called as the A. When traffic is coming from 2 but going to some other leg apart from leg 3, that is in this case leg 4 and 1 is called as our B. Then there will be traffic from the other legs of the rotary that will be coming and going to leg number 3. In this case, the traffic can come from leg 4 or leg 1. So when it comes from some other legs of the rotary and moves into the leg 3, that we call as the C. That we call as C, right? And then there will be a traffic that is neither coming from 2, neither going to 3, but is using this weaving section, right? It is using this weaving section. It is using this weaving section to reach to the respective leg. So that is what we call as the D, right? I'll again repeat, the traffic that is neither coming from 2 nor going to 3, but is coming from some other leg, but is using that weaving section, right? This is our weaving section that we are considering. This is our weaving section that we are considering, right? This is our weaving section that we are considering. So all the traffic that is coming from this and using this weaving section, that we will call as the D. I hope it is clear to you all. If not, then you can always ask in the comment section. So A is the left turning traffic moving along the extreme left lane, right? Or that is your A. B is the crossing weaving traffic turning right while entering the rotary, right? Crossing weaving traffic turning right while entering the rotary. So this means coming from the study leg and going to some other leg. C is the crossing weaving traffic turning left while entering the rotary. So all the traffic that is coming from a different leg and going to the study leg. And D is the right turning traffic moving along the right extreme lane, that is coming from any other lane and going to any other lane except our study lane. So that is what we define as the A, B, C, D. So your weaving ratio will be B plus C divided by A plus B plus C plus D. That will be your weaving ratio. Alright, I hope it is clear to you all. Okay, if not, you can always ask, right? So let us just quickly do a quick numerical on this weaving ratio, right? Rest everything we'll have a new video lecture on that, but we'll just discuss about this numerical on the weaving ratio. Okay. So in the question is that we have to find out the weaving ratio between leg 2 and 3. The traffic volume in PCUR is given in this table, right? So what we have is, first of all, let us draw one rotary, right? Let us draw one rotary. This is leg 1, this is leg 2, leg 3, and leg 4, right? Always move in the clockwise direction, right? Here V1 2 means vehicles coming from 1 and going to 2, right? Likewise 2 1 3 2, everything means first means coming, second means going. Okay. So we have to find out between leg 2 and 3. Let me just quickly write down the formula. Weaving ratio is B plus C divided by A plus B plus C plus D. So we have to find out between 2 and 3. This is 2 and 3, right? So let us draw the diagram for 2 and 3. Quickly let us draw the diagram for 2 and 3. So we have this leg, this is leg 2, this is leg 3. So first of all, we have to find out A. What is A? Vehicle coming from 2 going to 3. A will be V23. V23 value is 200. V23 value is 200. B coming from 2 and going to some other leg. Here in this case, other leg may be 2 to 3 or 2 to 4. So sorry, 2 to 4 or 2 to 1. So we have 2 to 4 plus V 2 to 1. Right. So V24 is 1090. V21 is 310. So the value is 1400. Okay. Just keep checking if I'm doing any calculation mistake. Right. C. C is all the vehicles coming from the other legs and going to 3. In this case, the other leg will be either it can be 4 or it can be 1. Right? It can be 4 or it can be 1. So we have vehicle coming from 4 going to 3, vehicle coming from 4 going to 1. Sorry. Vehicle coming from 4 going to 3 and vehicle coming from 1 going to 3. Vehicle coming from 1 and going to 3. Right? So V43 is 600 and V13 is 450. V13 is 450. So this will be 1050. Talking about D is any vehicle that is coming from some other leg and going to some other leg. So in this case, either a vehicle can come from 1 or can come from either can come from 1 and go to 4 or is coming from 4 and going to 1. So which we are going to take? We are going to take the vehicle that is using this weaving section, right? This is 2, this is 3. The vehicle that is going to use this weaving section. So if you see here, a vehicle coming from 4, this is left, this is right. We simply turn left, right? Vehicle coming from 4 will simply turn left and go to 1. It will not use this weaving section. While if a vehicle coming from 1 has to go to 4, he has to go through this weaving section and then go to leg 4. So D in this case will be V14, right? D in this case will be V14, right? And the value of V14 is 412. This will be 412. Clear? So just put the values. P will be B plus C. So B plus C. This will be 2450 divided by the A plus B plus C plus D, right? That will be 3062. So the value will be 0.80. Okay, the value will be 0.80. Okay, so the weaving ratio is 0.80. Okay, so you can try among by yourself also. You can try to find out for leg 1 to 2, 2 to 3, 3 to 4, and 4 to 1. Right? You can find out the weaving ratio and just you can post the values in the comment section, and we'll see who posts the right values. Right? And if in case you have any doubt, we are going to do some more numericals in the coming lecture. So keep a track of the upcoming lectures. Okay. So I hope this video was useful to you. Everything, the theoretical concept of rotary and roundabout and realized intersection is clear to you, right? If this video was useful to you, make sure you like the video, share this video with your friends, and do subscribe to the channel. You subscribing motivates us to make more videos like this. If you have any suggestions, do post in the comment section. So thank you for watching. Have a nice day.